Good afternoon. My name is Nozawa from Nikkei newspaper. Right now, I am an editor in business news department. I would like to be the moderator, and I would like to take about an hour for this session. Thank you very much. Thank you very much for coming to the Nikkei Global Management Forum. In this session, we would like to talk about robots and machine tool at the top manufacturers. Here we have Dr. Inaba from Fanuc Corporation, the chairman and CEO. And Preferred Networks, the president and CEO, Mr. Nishikawa, who is really the focus of attention in this industry. Since yesterday, we have had this forum titled Driving Transformation in a Fast-Changing World. In the disruptions, how do we manage our companies, and how, as disruptors, you can survive in this world? Those are the themes. Robotics and IoT, AI, are topical areas. Here we have two people from the top management of prominent companies who are very suitable for this session. First of all, just briefly, I would like each of them to make a presentation to introduce their companies. First, Dr. Inaba, please. Good afternoon. My name is Inaba. I'm the chairman of Fanuc. Fanuc is a B2B business. You might not know our company, so I would like to take about 5-6 minutes to introduce our company. The headquarters of Fanuc and also Research Institute and a part of our factories are all located at around the bottom of Mount Fuji, -15 to -20 degrees centigrade is the temperature during the winter. It used to be very, very cold. It's a very cold area, and this is where we are operating. Globally, in the group, we have about 8,400 employees. However, out of that, we have 3,700 Japanese employees, and the sales is about 726 billion, and the operating profit is 220 billion yen and over. So we have very good profit. If you are shareholders of certain companies, we might be very famous. We were in Fujitsu Group in 1957. We became an internal venture company in Fujitsu Group. From the original entity, we received orders. However, the management and the direction of the company was not really favorable by doing so. We wanted to develop our own products, and we wanted to sell our own products. And because of that, computer and the controller, CC, started to be our forte. Computers and controllers started to be developed in our company. We have software business in the computer division, and also Fujitsu doesn't have this business anymore. As for controllers, because of the uniqueness, in 1972, because of the controllers, we became independent from Fujitsu, and our history began since then. Today, here we have Mr. Nishikawa. As a startup company, he's here today. In those days, he was really individual, independent. But in those days, this was very a unique approach. That's why this was an internal venture company. But in terms of entrepreneurship, we are very similar as partners. In Fujitsu, we started a controller business for machine tool controllers called CNC. For machine tool, that was our main product originally. And we have industrial robots and also robo machine. And those are our three main pillars: automation and robotics in factories was the focal area for us. We narrowed down our focus in our operation. And these are our business divisions. We have FA, a business division, where we have the controllers and servo motors, razors, oscillators. Those are our products. And in the robot business division, we have industrial robots. When you go to our factories, you would know we are using a lot of robots in the automation. And also, this might not be known so well, but for smaller machine tool, we have more and more intelligent machine tool, and this division is growing. So we have such three business divisions in our company. Those are controllers and also intelligent machinery and industrial robots. Those are very historical products with decades of experiences. Higher speed and high precision and high performance of each machinery was important. However, nowadays, rather than individual strength of individual equipment and machinery, intelligence and also connectivity and also overall optimization are very important. Going forward, smart factory with intelligent factory systems is more important. Advancement of technology has been very, very fast recently. In such circumstances, as I'm going to explain, AI, preferred networks, and our company are collaborating in AI in factories. More intelligence in factories. In these 4 or 5 years, we are in collaboration in this AI area. All of our products are only manufactured in Japan. Nationwide, we have 41 factories, 35,000 NCs per month, and also 37,000 robots per month, and also 3,500 intelligent machinery per month. That's our capacity. And from Japan, we deliver all of their products. Unfortunately, however, domestic sales accounts for only 20%. 80% of our sales is from overseas markets. So only 20% domestic, and 50% of that is for transplants. So we have a machinery and machine tool for manufacturing industries. So we really would like to contribute to the manufacturing industry in Japan. However, 90% of our machinery is installed outside of Japan. Now we are entering the global society. In that sense, we are trying to globalize our operation as well.
Also, one Fanuc, service first. So that's our slogan. And now we are trying to be more global. And regardless of where it is, we like to offer the service support as well as technical support. And that's how we organize ourselves. And our concept of the development is, instead of having the higher quality, higher performance, we are trying to have the higher reliability. We should not stop the customer's factories. So it should not be broken down. It will notify if before it is broken down. And then even though it's broken down, it will be fixed immediately. And also 263 locations supporting the 108 countries. So that's our organization. And this is our global footprint. And we have subsidiaries and associated affiliations throughout the globe. We are pioneer, and we have 4.1 million CNC devices throughout the world. And the fields have the NCs and how we can connect NCs and how we are going to visualize the operation of those NCs are a big challenge. And also regarding this turbo motor maker, as a robot manufacturer, we already have 600,000 robots from ourselves. And monthly basis, it's 6,000 to 7,000 units manufactured at our factories. This is a robots for disaster recovery. It's not humanoid type of robots, but arm is used for the assembly or process. So we have so many applications in using our products. And also, this is one example. The motor. Well, this is one example. We have 41 factories and over 4,000 robots are in operation. Well, human beings can work during daytime shift, but robots can work full day throughout the day. Robots does not need the paid holidays. So 3 shifts per day, and we have the full capacity of the robots. I hope you will visit us because we are actually at the root of Mount Fuji. If you are nearby, please come and visit us. And thank you very much for your kind attention. Thank you. Thank you very much. So next is Preferred Networks, Mr. Nishikawa. The floor is yours.
Please give him a very big hands of applause. Thank you very much. My name is Nishikawa from Preferred Networks. Our company was established in 2014, so we have a brief history. Deep learning and machine learning are the technologies we are using and applying in the real world. That is our focus. For example, our focus areas are, for example, industrial robots and industrial machinery, and life science is another one. I'd like to talk about life science area as well. And now we have a new area, for example, a process industry and chemical industry are our new focuses. Life science first. As for life science, with National Institute of Cancer, we have utilized the particles in blood to enhance diagnosis of cancer. For example, for breast cancer, you are using mammography. The precision is around 80%, while liquid biopsy, that is particle in the blood, to diagnose breast cancer, the precision is 90%. However, this liquid biopsy data is used when we are using deep learning. This is the statistical method we were using, and we use deep learning instead now to enhance the precision to 99%. That is the technology we are developing. And so these are our R&D. And this is the announcement recently, National Research Institute of Cancer, and also DNA PFDNA is the joint venture with them, and we are in collaboration to deliver the technology to the world. That's what our aim.
この技術自体
So the technology itself is going to be feasible in 2021. That's our target. So this is a life science arena. And the other is this is more for the industrial machines, like machine tools and also industrial robots. We can apply the deep learning, machine learning to those robots. And that's another focus for ourselves. And that initiative is jointly developed by Fanuc. And because of the joint collaboration with Fanuc, we are able to start this business. Fortunately, our technology it's not at the research level. It's already commercialized. Let's say using AI or maybe the different methodology. This is far right. When it warms up and when it's ready, I think it is going to change the processes. So maybe depending on their temperature, you can actually change the process. And that's another thing which you are able to use our technology. And it's already commercialized. It's already in product operation. Where do we apply deep learning or the machine learning? IoT is going to be connected for the real operation. Maybe 1-2 years ago, we were still considering if it's going to be feasible or not. But now we have those technologies deeply rooted in the factory operation, and we were able to deliver those technology in the real operation. That really makes me happy. So data is analyzed, and for the tuning purpose, we do that as and IoT and machine learning can be multiplied to produce even bigger value. I think maybe we are able to do it with the maintenance of the machines, just not collecting the data, but now those are connected to each other. And using the machine learning, you can have the real-time data analytics as well as feeding back those data on the real-time basis. Then the device control can be a new area for ourselves to apply the technology. So robots, AI. So this is the first one, first project with Fanuc. So in the bulk, the robots can pick up cylinders. And it failed at the beginning, but once you start to learn, I think it's getting better and better. The image of success and failures are memorized, and then using the deep learning, they are going to learn. And then once it goes through a lot of different images, deep learning automatically learns how to successfully pick up those objects. And we have about 5,000 data, and 90% of the successes ratio can be achieved. So this could be the skilled worker. So it's just having the robots using a deep learning, you can actually teach from the scratch. And this really widens the opportunities for robots to be used in the factories. So first one is amongst all those boxes, you have to pick. And in the past, people have to write the program, but using the deep learning, it can be automatic. And that was our first project. Well, moving on to the robot arena, next one is not just one object, but different multiple objects. Well, I think you can consider this in the warehouse or distribution center or convenient store. You can pick up different things. This is assuming the convenience stores. So cup noodles or maybe chips and other snacks. And as you see in this demonstration, these objects were not used when robots were going through their learning process or teaching process. And the robots were able to learn from other objects. Even though it was not using those chips and others, robots can pick up those objects which are a little bit unknown to them. So deep learning is able to enable robots to pick different objects. Well, even though you have to have a program, you have to tune up for different objects, but using deep learning, you can skip those fine tuning of the programs. So almost teacherless, you can pick up the different objects. And then next is yes, we are focusing on the industrial robots, but not just industrial robots. I think our robots can be used in different applications. So in October, there is a SheTech event. And yes, of course, we demonstrated this industrial robots as well as personal robots. And yes, not just showing the determination of what we are going to do, but we were able to demonstrate some of the current level of those personal robots. The next demonstration is showing the tidying up robots.
ちょっと動画が出てこないので。
Sorry, yes, this one.
まあこれ今
This is 20 times as fast as it was the original speed. But anyway, well, using deep learning, the robots can recognize what's in this room, and then they will, or the robot will identify the shape or objects, and then trying to target where to grab. And of course, yes, it will carry to whatever places. Of course, it should not dump everything to the trash can. So you have to first show where it can be installed. Maybe the slippers, you have to make them as pair. So assuming this to be used at homes, we are now implementing the functions or features which could be useful at homework, housework. I think you have to put them on the shelf, and you have to put softly. Well, this is at the development stage, and some objects are hard to be grabbed. When robots did not recognize it appropriately or correctly, it will not be able to grab. So you have to really improve the accuracy of the vision. And that's where we focus. We had different conditions in terms of the lighting and trying to collect the data so that it can accommodate different situations or scenarios at home. Well, sometimes it's quite thin, so maybe you can actually try to slide them. Well, this we are trying to accelerate R&D, and yes, we are able to show different outcomes. And the reason behind this is we have now good infrastructure technology. One is a chainer. This is a neural network architecture, and you can write it with flexibility. This is a framework, and 9th of June 2015, we actually make it open so that deep learning methodology itself can be accelerated in terms of their development. And also, the data volume is really important for the deep learning. So it's not just one GPU, but many GPUs in parallel, so that trying to accelerate the computation, trying to accelerate the training process. And this is where we develop our own technologies. For instance, Google Open Images in August in this year, we were able to show that demonstration. This is 512 GPUs at a huge cluster, and trying to really show the parallelism, and then trying to accelerate the experiment cycle. And we are just runners-up, slightly off from the champion. There are over 400 teams in this contest, but I think we worked quite good, trying to show the huge computing environment using this technology.
でも私たち、このような
So these are our activities. We have those four visions. These are very important. These are our values, especially what I think is the most important is the second one, learn or die. You have to keep learning. This is the most important thing for us. We are now focusing on only software, but to understand hardware is very important. Going forward, I myself think the border between the software and hardware is going to be more and more blurred. Software accelerates hardware, and the advancement of hardware might impact on software. So those two used to be very different. They were separate. However, the border is more and more blurred. In this situation, what is important is both. You have to understand both of them. And everything is connected in the network. So network, hardware, and software, all of them should be learned. And the advancement of technology is remarkable. You have to keep learning. In this advancement of technology, that's the most important thing. That's the culture of our company. Thank you very much. This is my brief explanation about the company. Mr. Nishikawa, thank you very much. Dr. Inaba, once again, could you please come out on the stage?
はい、じゃあどうもよろしくお願いします。
お二方プレゼンテーション
Thank you very much for the presentations, both of you. Now I would like to have a discussion with both of you. Now we heard the presentations. Those are representative robot manufacturers, Fanuc and AI deep learning company, Preferred Networks. In the manufacturing, we have new approaches. For example, for smart factories, they are in collaboration, which is very interesting for us. Personally, I think this kind of combination and initiative really represents the clue to survive in this disruption. They are very different companies. So, Dr. Inaba, what was the trigger for you to start collaboration, Fanuc and Preferred? How did you start? Well, that was about 3 years ago, a little more than 3 years ago. Of course, automation is very important for us, and robotics was our focus as well. So, of course, intelligence was our interest as well. However, what we were doing was mostly for arms and machinery. Movement of the things was more of our focus. However, we thought, well, connectivity should be more important going forward. And in one occasion, I met Mr. Nishikawa, and I'm sorry to say, that time I thought, okay, this would be the person who would change this company. He's wearing a jacket today, but as in the IT industry, usually he is always in T-shirts and jeans on the street. Well, he's just another young man, but his eyes were really glowing, and what he talks about was really significant. And in those days, well, what he was doing, he just explained what he was doing in those days, and I could really feel this intuition that we had to do something together. So you are like a father and son, but you didn't really feel the difference? Not really. So you wanted to put your company at stake? Well, yeah, and you decided to invest into this company, right? Yes. Mr. Nishikawa, well, Fanuc is located in Yamanashi Prefecture. You said it was a shock for you to know about Fanuc. What was the shock? I myself didn't really have any connection to manufacturing because what I was doing only was computing. So I was kind of withdrawn from the society. from the morning, I was in front of a computer all the time, and I joined the society, and I was doing the computer as well. And for the first time in my life, I visited a factory. So the very first factory of my life was Fanuc. I was so lucky because of the precision of robots and machinery. Robots are precisely making machinery. And I don't really think there is any other factory that's more automated than theirs. They don't have people, so there is a future there. And I was talking to my own vice president, very, very close to singularity. They were the ones who were the closest to singularity. It really was a shock. So what kind of potential did you feel? The robots were very, very precise in operation. This precision was remarkable. Human beings can handle unpredictable events. So in such capability, I think human beings might be better, but industrial robots can do precise works, precise movement is what they are very good at. That's remarkable. If they have more flexibility like human beings have, productivity would be really enhanced. That's what I thought. You had to tune the robots for bulk boxes and products. But if we could give more capability of flexibility, I thought robots' capability would be more and more enhanced. Right now, the baseline is very high. A higher advancement of software, there should be more gaps. So I thought this was the direction. Your common concept was edge heavy. That means vis-a-vis cloud computing, big data is not handled by servers, but at the edges, you can handle the data, for example, in factories for more efficiency and optimization. Could you elaborate on that, Doctor? Well, edge computing and cloud computing have their own forte. And we are doing robots and machine tool. High speed and precision are very important in our operation. In that sense, unless you have very quick response in milliseconds, for example, to avoid a crash of robots, well, you really need precision. And also, for example, a precision of communication is very important. You cannot interrupt the operation because robots might crash. So precision is very important in our operation. And such big data are coming from a lot of sensors from the edge. You cannot really use cloud. You cannot really upload all the information coming from the edge to the cloud. As much as possible, we'd like to process them at the edge. In that regard, robotics and a controlling machine tool, AI that's used for that at the edge is very important. And the statistical processing and also production plan, manufacturing plan can be within the cloud. You can wait for the computing in the cloud. And when it comes to security, on-premise processing, in reality, should be more prevalent. 3 years ago, that means edge computing was not really a major concept. Still, cloud computing is very popular. And Mr. Nishikawa, do you think cloud computing is going to face a limit? Well, in those days, I was not really thinking that far. There were so many cloud experts. So we thought that, okay, you have to go against the cloud to win in this world. So first you have applications, and we focus on edge heavy. That was not what we did. We thought edge heavy was the only area where we can win. Fortunately, Yuva does That was an open source framework we developed, and also edge computing was very fast, but there was no application. Only one server can be used to extract data and process the data. So we didn't have any applications, and surveillance cameras as well. Well, if it comes to 5G era, it shouldn't be a very difficult technology. So I was really struggling to find my direction. That's where we met Fanuc, and offloading of processing to reduce communication cost. That was my idea when we used the edge. But Fanuc is using the robot and edge processing of the information coming from robot, and also latency can be minimized between the robot and the machinery. And that's something cloud computing cannot do it, because 200 millisecond is very far in terms of distance. Higher vision and visual feedback is possible in such high precision. So I finally found the area where we can pursue the potential, and that's why I just believed in edge computing.
So talking about the 40% improvement in terms of their machine tool efficiency. So using preferred AI, what else is going to be enabled at Fanuc factories? Well, the S displacement compensation and also mass flow compensation, or maybe there are already different interesting things which are enabled. When we are trying to tune up the NC, if human beings are trying to do it, I think so many parameters to tune up, so it is getting really not possible. So when human beings are involved, we are trying to really limit the number of the parameters and trying to use the approximation. However, what was quite surprising is in case of deep learning, it does not really make difference if you have so many parameters. So if we are going to have the really appropriate parameters, or if we are trying to really have a good tuning, then you have to have a lot of parameters. Maybe in the double environment, this is going to be quite innovative technology. So tune-up is one issue, which can be solved with the preferred networks AI. And also the other is a real timeliness. Well, machine tools, when you are setting up the condition, then vibration or sound, and based upon the past experiences, maybe machining speed should be this much, or maybe you should cut to this depth. So the machines and also the capability of the knife and also the human experience are the keys for the tuning up. However, of course, it has to be safe, so that's why it tends to be more conservative setup. But now using deep learning, those human experiences are now digitized, so you can looking at the machining condition and trying to really put the machines or robots in the most appropriate or best conditions. And that also improves their productivity. I think regardless where you are in Japan, I think skilled workers are retiring, and we want to really digitalize or digitize those skilled workers' experience in our system. Nishikawa-san, using deep learning, what you see the future factory shop floor using the deep learning? I think it will even automate more. Even at the Fanuc factories, you already have quite a few number of the people, less number of the people, but let's say the strings, it kind of swings. So that's why it's really difficult to compensate when it's swinging. And it's really difficult to make the program. And even though using the current status of the deep learning, it's really hard to predict the behavior. It may not just be only predicting, but if improve the performance. You can have the real-time behavior analysis. And also, it will improve the simulation performance, and that will automate even more. Maybe the simulation accuracy is going to be improved. Currently, when you have the simulation, it's not that high accuracy. So from the hardware experts, simulators sometimes may work and may not work at other times. But simulation accuracy using deep learning technology, it will really improve the accuracy. Then I think you can copy the real world more easily. Then I think maybe you can create the virtual factory in the supercomputer so that you can do the simulation and you can do the learning. So maybe it will be getting more closer to the software. Now, we have specific questions to two speakers. First of all, Dr. Inaba. Fanuc is a top or leading company for the factory automation. Talking about the IoT platform, filling system, you are trying to really deploy that IoT platform. Well, robots or machine tools or FA devices are not satisfying your desire, but now you are moving to the IoT platform. It's more like the OS. Why did you decide to go into that area as well? As I mentioned before, we were creating robots and trying to create the machine tools, and we always try to improve the accuracy of that standalone machines. However, it's like a single cell organism. So even though you have the development and trying to really have the evolution, I think you have a certain limit as long as it's a single cell. Well, you have to evolve to the multi-cell objects, then it will connect, and maybe you have a distribution of work between different cells, and that will even perform better. So as you hear, the connected industries or Industry 4.0, trying to connect and trying to visualize. And I think we have to go beyond that, how you can smartly use the collected data. If you're successful, then the factory can be more autonomous and trying to make decision on its own and trying to be more productive factory. I think this is more efficient and more rational to improve the productivity. If certain area is down, then we have some other system which can supplement the lack of those capabilities. So for that purpose, we need platform. It's not just our products, but everything in the factory, every device, every sensor can be connected on our platform. That's what we are trying to achieve. And as far as specification is met, then third party can bring their own proprietary software onto our platform. So it is a flexible, open platform. Then we will be able to evolve from the single cell to the multi-cell objects. Okay, then in the manufacturing or production, do you think you are kind of threatened by the other competitors if you are not sticking with this concept? Well, yes, FN and deep learning AI technology is available in Japan, and also our proprietary technologies are also available, so maybe we can combine those technologies on our platform. And also, we have already 4 million NECs, and we have already over 500,000 robots. So throughout the world, we already have the devices throughout the world, and I think we know the best. So Siemens from Germany and also GE from the US, they also are trying to do it on their own. What's the strength of Fanuc? Okay, first one is edge heavy. You know, all the other players are cloud computing, but we are edge heavy. And NC and robots, I think usually it's already man-made or artificial. In terms of the NC and other automation, we only have a lot of population using our products. So how many customers and what kind of customers you have? Well, as a customer, application is under development. So we are not trying to expand too much, but OEM, car manufacturer, or processing company, and also internal use. So we do not have so many customers, but at the event, we have 84 field system platform to be sold or to be borrowed. And throughout the venue, we have about 300 machine tools connected at the event. Once you know how it works, I think they will love it. Yes, there was an event or exhibition of the machine tools. Okay, yes. So talking about the main products, the industrial robots, I think Chinese companies are growing quite rapidly. Industrial robots, Fanuc is a leading company, but the KUKA, which is a second company from Germany, and it was acquired by Bitek Shudan from Chinese. And also made in China 2025 is also another philosophy. China is also trying to evolve itself. So Fanuc also is using those drugs as well. Are you going to go into that area? Yes, of course. China has a lot of talented engineers, and I think the population itself is big. So under the circumstance, the strong companies will emerge from China. I think highly likely we will see that situation. But US, Europe, and also Japan, we were already exposed to the severe competition, and now we have another competition from China. So the overall picture is not changing too much. So we have to be a top runner, otherwise we will not be able to survive. Okay, more recently, today, I think the midterm election is now coming up. It's going to disclose the results, and the trade policy of the Trump administration is going to get more attention.
So Fanuc, well, because of the Chinese investment, which is really declining, maybe you're focusing this. What do you think of the movement? Well, this might not be relevant in this seminar, but so far, right now, well, the judgment of the Chinese manufacturers and also Chinese CEOs are still waiting. So if they would invest, well, if it's very necessary, they would invest. But if they can wait, I think they are waiting right now. So demand for machine tool right now totally is declining. Do you have any countermeasures? No, we have to just wait. The market shrinks. Of course, we try to expand our share, of course, but we don't really lower the prices because that would distract the market. We would rather wait. That is our strategy. I think that's one of the strategies we have to take. Yes. Well, I think you have been to a lot of trade shows globally, and you have visited a lot of factories as well. Industry 4.0, well, Germany started to say that, and it's been 7 years or so. Well, this Industry 4.0, how prevalent it is right now? Well, I don't really like it because 1987, from Japan, IMS project started. That was actually the origin of Industry 4.0. So smart factories concept was proposed by Dr. Yoshikawa of Tokyo University. IMS was the very original concept. In this industry, this concept is really common sense. So they are using the term politically to say Industry 4.0. They were very good. In Japan, we have IMS project for 20 years, but that was the end of it. I'm very sorry about that. So in the Industry 4.0, what's the position of Japan in terms of manufacturing? I think our position is very important. We are very close to the edge. In terms of such kind of technology, we do have the accumulation of the technology. And what we were lacking was AI technology. Fanuc, AI, and the other AI manufacturers. We have the technologies for manufacturing AI and machinery equipment. We do have the accumulation of it. So how we can make good use of AI is the future. This is going to be a new area. So with preferred networks, we would like to together strongly disseminate this new technology from Japan. So I have some questions to you, Mr. Nishikawa. In 2006, you established this company as Preferred Infrastructure. This was a search engine company. You established this company with your friends when you were in college. And Preferred Networks was evolved from that. What was the trigger for that? Since PFI, we were doing machine learning technology, but in those days, machine learning technology couldn't achieve good precision unless you do individual tuning. So we were facing a success, but we couldn't really reach it. Deep learning really was disruptive. It was a shock for us. We were like, it's so precise. The precision was remarkable. In reality, we were able to use that technology. And in those days, IoT was another wave. Devices were getting connected to the network. So deep learning was used to obtain data from sensors. And if we can use it in the earlier stage, if we can do it, I thought we could be on the same ground as the other big companies. So I couldn't really wait. I wanted to shift toward this area. So that's why we did a spin-off to restart. Search engine business, I think, has been very successful. Had been very successful, right? But there is no hesitation. Well, we would be perpetually a Google follower if we were to pursue it. As an engineer, I wanted to create something which is not comparable. I really wanted to make something very unique, so I didn't really hesitate. I thought that was the only area I should go to. That was my start. So it's been 5 years since then, and during the time, other than Fanuc, Hitachi, Toyota, and NTT continuously invested into your company. Well, a unicorn company, which is so rare in Japan, more than $1 billion should be the market cap as a unicorn. So, so many major companies were attracted to your technology. What do you think is the strength of your company? Well, our team, not only software, but we do hardware as well. And we have a variety of knowledge about hardware as well. And we have partnership like Fanuc. With such partners, we are very closely cooperating, and we can deeply understand their technologies. That is a major strength of ours. And basic researches are our focus. In the applied area, you have to do many things, but before that, trial and error should be done, and the cycle should be shorter. For example, when the computing environment is slow, even if you have very good researchers, you have to wait for a long time. So you need to provide a good environment for researchers. to enhance their capabilities. That's our focus too. And when you collaborate with large enterprises, you have to be specific. You have a policy that we are not a subcontractor, right? Yes. Because we wanted to have a partnership, equal partnership, to develop technology together. Because when you are a subcontractor, you just receive orders, and the idea is in the counterpart, not in you. So you have to be really frank to discuss, and you have to look at the same direction. That's why I wanted to select only partners with whom we can go to the same directions. And in biohealthcare, you were talking about cancer by using hematology, blood samples. Like that, using deep learning. Do you want to explore some new areas? Life science. We are doing life science for more than 10 years. The trigger for my company was because I was working for a bio venture. That was the motivation. Since then, I was very interested in bioscience, biotechnology. In the bioscience area, the utilization of IT technology was not really advanced because of the gap between scientists and the IT engineers. But I really wanted to innovate something in the life science. And then I met National Cancer Center, and well, it was very difficult for researchers to understand deep learning. But National Cancer Center staff members were very different. The researchers said they wanted to utilize deep learning, so they gave us data. And so the collaboration was very, very fast. And then we achieved to be in this stage. So using deep learning, what kind of other areas in the society you can explore to solve issues? Well, right now, in the collaboration with Fanuc, especially assembly type in manufacturing or processing, for example, semiconductors, and also chemical area and energy area, construction area. Well, in the past, even if they had data, they couldn't deeply analyze the data in those fields. So right now, there are not good progress. But we have so many things we can do. That should be the next big wave. For example, materials as well. So going back to common questions to the two of you in terms of management capability to manage a company and competition, data, capital, and big data are very prevalent right now. Google, Amazon, Facebook, Apple are dominant in the market. And in your collaboration, processing of data is very important. And competitiveness of companies should be really centering on data. Yes, of course, data is very important, but what we are using is not ordinary data. Data from the manufacturing sites, how to collect the data to make the best use of only necessary data. That is very important in the earlier stage.
データの量がも
Yes, I think the volume of the data is going to be the key for sure. However, not just having just a data, but once you start making mistakes in how to collect the data, maybe it's just a garbage of data where you are going to place the sensors. In terms of the thermal displacement compensation, if you put the sensor at long location, I think you are not going to get the good data. So you have to get the expertise in terms of how good the data is, and then trying to process the data. So how data is generated is something which you have to learn, and also the data volume. Those are the two important axes. Well, Silicon Valley companies, over 100 trillion yen as the market cap. And I think, yes, it's a huge gap between Japan and those US Silicon Valley companies. And I think we start to see it's a little bit lagging to see the Japanese companies making innovation. Well, the Japanese monozukuri or manufacturing production going to kind of dominate the world with innovation. What kind of foundation is necessary so that the Japanese companies can really demonstrate the innovation capabilities? Well, as I said in my presentation, the software is actually not really good in Japan, but the boundary between software and hardware is going to be blurred, and then eventually it will be fused, and that will bring a new arena. So that's the key for Japan to be able to dominate that new emerging area. Well, Japanese people are really good at the fields, at the shop floor, in the fields. Other countries, maybe the engineers and operators are differentiated, but in Japan, engineers can go into the shop floor to do the operation. So maybe in the manufacturing industry, yes, Japan was really showing the greatness of the production or manufacturing itself in the past. Well, we have that skill, and I don't think that has changed. We have the expertise or skill in manufacturing. Combining with the AI and IoT, so on top of the manufacturing technology, we have AI and IoT, and that will bring the great innovation in manufacturing. And that can be dominating throughout the world, and that will make Japan as the top country in manufacturing. That's possible. Well, Japan has been strong in manufacturing, and now we say from the products to experiences. So maybe I think in this regard, Japan is quite unique. Well, the manufacturing innovation, if we are trying to bring the manufacturing innovation, I think we have to have a good talents, and we are in shortage of those talents in terms of the AI or IoT area. So Fanuc, how do you attract the talents? Well, for sure, IT engineers, not just IT engineers, we always are insured in terms of the labor force. And we are always trying to be creative in trying to make up for those shortage. Well, I think I saw the results that Japan is suffering the IT staff shortage, but I am quite optimistic. Well, if it's necessary, then the Japanese engineers are very talented engineers. And I am sure that they are able to learn whatever skills required. So AI or IT engineers, maybe they may not be the names of IT or AI engineers, but I think we have a quite great talents in terms of the engineering. What about you, Nishikawa-san? Yes. Now we can attract the researchers from other countries, but we still have great talents in Japan. And they are not able to show their capabilities. So we try to really soften up those binding so that we can bottom up the talents. On the other hand, we have to also train and educate the people who are both good at hardware and software. Well, from the elementary school, I was devoting myself to the programming. And I still have that philosophy. So I usually say that even at the elementary school, we have to do both programming and also hardware. Because I started to do the programming from the elementary school, it's already a part of myself. And I think at the grade school, we have to teach both software as well as hardware so that they have no problems in learning and they don't really have to put the line between hardware and software. That's something which is necessary in our education system. Well, of course, once you join the company, we have to teach and train so that the employees can learn. We also are having a great internship program, but now we are trying to approach to the younger generation and trying to offer the educational program so that the students have not resistance to this kind of training. I totally concur. I totally agree. I think half of our population is females, but basically the Japanese government, they are voicing out, they are trying to promote more women, but basically they are doing nothing. So the chemistry, IT, design, architecture, they may have some female students, but the machines and others, they do not entice the female workers. I think IT will have more female workers, but the electric and machinery, the electric and machinery are least popular amongst the female students. It's not just mechanical. We have IT and information for electric and also the machinery engineering. So it's more like a comprehensive skill necessary. And I hope, yes, the younger generation will learn those skills together with the language skill like English. Well, I said those two companies were totally different in nature, but as I hear your discussions, you keep trying to bring the innovation. So there is commonality. Innovation itself is going to be the driving force for the corporate competitiveness. So under the circumstance, what kind of leadership do you want to show? Well, training or education is one, but in my case, I already have highly intelligent employees around myself. Maybe what's the difference is I think it's a leadership. Leadership is your determination. Once you decide to do it, you are just going to do it, and you should not be afraid. Sometimes you face failures, but you should not be too much disappointed. You have to recover from failure. And also, you don't really worry even though you are ashamed. Otherwise, you will not be on this kind of stage. What about you, Nishikawa-san? Well, I talked about the PFA value. And yes, we need to really think about, I really have to show it, my philosophy, and it should be a part of our culture. And I think not just reading books, and not just studying on your own, because there is a certain limitation. So we try to break the wall between the departments or divisions within the company so that we can learn from each other and trying to lead to the new technology. That requires energy because once you are accustomed to do certain things, I think you are not going to do something new. So I think it requires energy, and that will bring the enthusiasm in your company, and that should be the responsibility by the leaders. Well, we are running out of time at this Nikkei Management Forum. Some of them are participating in the special workshop, and I have questions from those participants to both of you. Do you have any experiences that you actually changed yourselves? Sorry, because I have a thick face, so I don't really have any aha moment. Well, as I said, my passion and not afraid to do or to try things. And I had that moment. It was quite late, but maybe in the 30s, after I became 30s, I think I started to be aware. I was not really outgoing, and I was more like inward looking, but I do step by step. So when was the moment for you to really change yourself? Well, quite an impressive moment for me. It's really hard to explain, but Dr. Inaba made the investment to my company. I had a discussion, a talk with you, and that was quite impressive. Dialogue, conversation. I was CEO, and I was in front of the company, and I was talking to the chairperson, Dr. Inaba. I was really, really nervous, and I was really almost vomiting. But that moment, I was responsible for my company, and I tried to steer my company toward the positive direction. And at the end of the day, yes, we started the joint project. But if I failed, I would not be on this stage. So that was really the big moment for me and for our company when I'm at the table for that collaboration negotiation. Now I can talk to you, Dr. Inaba, but every time I had to meet you, I was really, really nervous. But I had to take my courage and trying to be in front of Dr. Inaba, and that was my determination moment, and that was a huge, huge experience for me to bring me to the next level. Well, thank you very much. I think it's time to close this session. Well, I hope that this discussion is going to be a bit of your tip for your work from tomorrow. Thank you. Thank you very much. Thank you very much for your kind attention.
じゃあどうもじゃあありがとうございます。
Thank you very much. Thank you. Thank you very much.
稲葉様、西川さん。
Thank you very much, Mr. Inaba and Mr. Nishikawa and also Mr. Nozawa.
それでは引き続き、
So now, continuously, we would like to go into the next